Okay, this is topic 0, the first quiz. It says explain, quiz review, which the quiz is tomorrow. Explain why you end up solving two equations when you are solving an absolute value equation. Be sure to include the definition of absolute value in your answer. Remember, absolute value by definition is the distance from 0. Good morning. I'm glad you're here. Okay? Glad you're here. Absolute value. Can you guys see this in the back? Can you see it? Monty, can you see it? Okay, absolute value is the distance a number is from 0. I put a little line through my Z's because they look so much like 2's, okay? You will have two values. You will have two values the same distance from 0. One of its values, one of these, is to the right of 0, which is positive. The other is to the left of 0, and is negative. So when you have an absolute value equation, you're going to have two equations, one to the left and one to the right. Correct? One to the left, one to the right. Okay. So, this first one here. All right? I'm going to let you solve it right now. I'm going to pause this. Okay. Now, you might have put these two in different order. It really doesn't matter. I like to do the negative first just to get in the habit of when I do inequalities that that interval notation always works from left to right. But you could have put the positive first. It doesn't matter, correct? Because they're not ordered pairs. They're both solutions, right? How many got this one right? Okay? And you can check it. 2 times negative 9 is negative 18. Plus 6 is negative 12, and the absolute value of negative 12 is positive 12. Put in 3, 2 times 3 is 6, 6 plus 6 is 12, absolute value of 12 is 12. So they do check, don't they? Okay? All right. Any questions on that? Now, there was one in Schoology, and I'll remind me to do that one, Omani, the one that you asked me to do, that you talked about. I'm going to do it as well later after I do these reviews. That was in your homework, okay, because it was a good one to do. Okay, everybody do the next one, and I'll pause this. I'm going to show you that everybody get 1 and 3. Now, let me show you something real quick. All you have to do is plug into the right side, and if you don't get a positive, it's extraneous. Does that make sense? When you have a variable on the right side, those are the ones you need to check. So if I put in 1, what's 1 plus 3? Positive 4, so I'm okay. Does that make sense? Put in 3, what's 3 plus 3? It's positive, so they both check. Because the absolute value can never be what? Negative, because distance can't be negative. Does that make sense? So just like this one here, no matter what I get for x here, if I plug it in, am I ever going to get a negative to come out of there? So this one here is no solution. Because distance can never be negative. Now you might get a negative solution, But when you plug it back in, it better not give you a negative. Does that make sense? There's no, I don't care what you put in for x, you take the absolute value, you're going to get a positive, aren't you? Can it ever equal -3? No. And you could on your quiz tomorrow, write the two equations and solve them and go plug them back in, and you'll notice that neither one of them work. Does that make sense? Because you'll get a positive over here, which will never equal a -3. Okay? Make sense? Okay, this one here is 0, and I think I did it like this. Really, you don't need to use positive or negative. Now, inequalities you do, but not with the equal sign. So you're really only going to have one equation because 0 is neither positive or negative. Okay? Inequalities, you're going to have to write two different inequalities when you have 0. Okay? All right. So subtract 2. Now, what are you going to do to both sides? Multiply by the reciprocal, correct? Right? Because you're going to divide by 2/3, but when you divide by a fraction, you're actually multiplying by the reciprocal, correct? And the reciprocal of 2/3 is 3/2. Okay, I want to show you something here real quick. Everybody watch. I was helping my Algebra 1s yesterday with this. This is how you do this. Take -2 times 3 is what? -6. And then divide by 2 is what? And you're done. Take this times this, and then divide by that. Now, sometimes you'll multiply those two together and it won't divide equally. Right? You won't get an even number, so just write it as that fraction. Okay? Say you have something like this, hypothetical. 3 times 3/5. Okay? So what's 3 times 3? 9 divided by 5. 5 doesn't go into 9, so you'll just write it 9/5. Does that make sense or no? Huh? Okay, number 3. Okay, I think I just talked about this. How do you know if an absolute value equation is going to have no solution? What's it equal to? A negative. If the absolute value is equal to a negative. You can have negative solutions, and like I said that too. You can have negative solutions however, this is different than, for example, the absolute value of x equals -5, for example. Okay? I write my two equations, 5 and -5, right? Well, if I put in 5, what's the absolute value of 5? Can it equal -5? No. I get -5. What's the absolute value of -5? 5. Can it equal -5? No. That's why. So you can get a negative solution, but when you plug it back in, it can't equal a negative number, can it? Okay? Does that make sense or no? All right. How do you know if the absolute value inequality is going to have no solution? If the absolute value inequality is less than a negative. Make sure you say less than, or you could also say less than or equal to, right? Agreed? Could be either one of those. Agreed? So if the absolute value inequality is less than or equal to a negative, then a negative, for example, can't be one like this. Absolute value of x is less than -5. No matter what you put in for x, you're going to get a positive, correct? For your solution. Can it ever be less than -5? Huh? No. No way. So that's why when you have an absolute value less than a negative, there's no solution. Okay? Okay, now we're dealing with tolerance, which is what we did yesterday, correct? Do we have some more on there? Yeah, I didn't do 5 and I didn't do the absolute, I didn't do the inequalities, did I? Okay, so let's do those. You guys have inequalities on yours? Yeah, we should have. Well, my notes don't have it for some reason. Your notes do, my notes don't. Okay, so we're going to have two inequalities, aren't we? Correct? So the first one, my negative side, my left side, copy it down, reverse the inequality, and negate the number. Agreed? That's the left side. The second side is just copy it down, this is the right side, and get rid of the inequalities. Or excuse me, get rid of the absolute value. Okay? So I subtract 3, I get -6, and then I divide by -1. But when I divide both sides by a negative, what happens to the inequality? It reverses, doesn't it? So this is going to be +6. Now I got a question for you. I didn't tell you that this is less than. Is this an and or an or? It's an and, correct? It's an and. Agreed? If it's less than or equal to, or less than, it's an and. If it's greater than or equal to, it's an or. Agreed? Let me put that up there for you just to make sure everybody knows what I'm talking about. If it's less than or equal to, it's an and. If it's greater than or equal to, it's an or. This one here, subtract 3. Divide by -1. And I have to reverse inequality. Now, what do you notice happens when I divide by a negative there? Reverse inequality, but what do you notice about these numbers? Are they in the right order? Huh? 6 is not to the left of 0 on the number line, correct? So that's what happens when you divide by negative. So what I do is I put 0 here and 6 here and x in the middle, and then I write my inequality. That's how it should look, correct? On the number line. Why do I do that? Because then it makes it easy to write your interval notation, correct? Because interval notation is always left to right. So then I'm going to go 0 here, 6 here. It's got an equal sign, which means closed circle, correct? Everybody awake? Closed circle, and connect. And then my interval notation, it's a bounded solution, which means infinity is not involved. So I have 0 to 6. Both of them are included. Okay? This next one's an OR problem, correct? Or, so, first one's going to be 1/3 x plus 4 is less than -1. And then the second equation, and this is an OR, and the second one, just copy it down, correct? Without the absolute value symbols. Okay? Subtract 4. Multiply both sides by 3. So I should get that. Agreed? This one here, subtract 4. So that gives me negative 3. Multiply both sides by the reciprocal, which is 3. So I get negative 9. This is an OR problem. This is your solution. Okay, so we've got negative 9. Agreed? And negative 15. Both of them have what? Open or closed circles? Open, non-included, correct? So open circle here, going that way. And x is greater than negative 9 is open circle going the other way. Agreed? Correct? And interval notation, you work left to right. Agreed? So arrows pointed to the left, so negative infinity to negative 15. Non-included means parentheses, right? Notice they're going in opposite directions, so you have to connect them with an OR. In the ACT test, they won't write OR. They'll probably write that little union symbol. Correct? But in Schoology, you do OR. Agreed? But you need to make sure you're aware of that little symbol. That means OR. And then negative 9, non-included, to positive infinity. And there it is. This makes sense? What about this one? No matter what I plug in here, what am I going to get on this left side? No matter what I put in there, I'm going to get a positive, aren't I? Isn't it always going to be greater than or equal to negative 7? So this in here would be what? All real numbers, correct? Because let's say I get 0 for y. What's 4 times 0? 0. What's absolute value of negative y? 9. Is it greater than negative 7? Yeah. Pick a positive number. Say, I don't know, 10. 4 times 10 is 40 minus 9 would be 31. The absolute value of 31. Is it greater than negative 7? Pick a negative number. Say negative 3. Is 4 times negative 3 is negative 12 minus 9 is negative 21. The absolute value of negative 21 is positive. So no matter what I get for y here, it will always be what? Greater than, won't it? So this one here is all real numbers. So your graph would be this right here, and interval notation would be negative infinity to positive infinity. Okay, can anybody give me a real life situation where you tolerance is involved? I can think of a plane. My dad used to be a machinist, and they were subcontractors for Boeing. And he would measure it with a micrometer. Now that everything's done with computers. You guys know what a micrometer is? It goes on there, and it measures, pinches right here. It measures what how wide it is. So when he would do it like a part of a plane, like a part of a wing, he would have to take his own micrometer and measure it. Now they have computers that do it, correct? Because this was 50 years ago. He had a certain amount that wing had to be within plus or minus 10 thousandths, correct? So there's very little room for error. Okay? Because you can have very little room for error when you put that wing on, correct? Because it could be catastrophic, couldn't it? Agreed? Wake up. Another thing is, I was thinking about when they torque, anybody work at a garage? When you torque a wheel, there's a certain amount of torque that you can put on that, plus one way, negative the other way, correct? If you get it too tight, burn something up. If you don't get it tight enough, the wheel falls off. Does that make sense? You have to keep it within those ranges. Okay? Like I went to Costco the other day, and I have to get my wife a set of tires, which tires are unbelievably expensive. It's about $1,000 for tires. Last time we bought tires, it was $600. They went up $400 in 3 years. Okay? $400, $1,000 for tires. So, you'll see up on the wall, a lot of times when you go to a garage, that they'll have different, you'll see measurements of what they're going to keep those, of the torque on your tires when they do it, when they put them on. Does that make sense? Okay. I just gave you some real life examples. I think I gave one yesterday that was about cereal, correct? Right? Cereal. Okay, an elephant is the heaviest land animal on Earth. Okay? Their mass varies from 3,600 to, so this is the least amount they could weigh, and then this is the greatest. Correct? So the first thing we have to find is the mean, don't we? The middle. So the mean, does everybody agree with me, is equal to 3,600 plus 6,000 divided by 2. So does that come out 4,800? I think that's correct. So here we go. So here's the least amount. Here's the greatest amount. And my mean is right there in the middle. Agreed? Correct? Everybody see what I'm doing? Some of you need to see a picture. This helped me. For you visual learners, correct? I was a visual learner, still am. Okay, so now we need to find the tolerance, which is from here to here or from here to here, correct? So how do we find the tolerance? That's right, 6,000 minus 4,800, and we get 1,200, agreed? We could also take 4,800 minus 3,600, and we get the same thing for the tolerance, agreed? Correct? So we can write our inequality. So x minus the mean, or the middle, correct, or ideal, agreed? This is always minus, isn't it? Correct? Absolute value, this is always less than or equal to, always. It's an and problem, isn't it? And then what was our tolerance? 1,200. Kids will do multiple mistakes here. They'll forget a minus, they'll put a plus. They'll flip-flop these two. The tolerance is always on the right, correct? And this is always less than or equal to. It's always an and problem. Okay? Rochelle builds chairs for a furniture store. Before she can sell them, each chair must measure 80 centimeters in height. So that's the ideal, or actual, with no more than a 2.5 centimeters error. There's your tolerance. So x minus 80 centimeters, absolute value, is less than or equal to tolerance. This is the easiest one, isn't it? This is your actual or ideal. This is your tolerance. This is always going to be this, isn't it? It's always going to be that. Always, always, always. This is always going to be minus, always. And then this will always be x. Question 4 on day 2. C, homework. How many in here can solve this equation right here? How many can solve that one right there? Raise your hand. If you can't, you probably shouldn't be in here. So to solve this one, what would you do first? Does everybody agree with me? Subtract 6. So we're going to do the same thing here. Agreed? So then what are we going to do here now? Divide by 2. Agreed? Everybody see I'm comparing these two equations? So does everybody agree with me? I get x equals 6. So what am I going to do on this one here? Think of this one here as an x, right? This whole absolute value is an x. So what would I do to both sides? Divide by what? 2. Isn't that what I did over here? Huh? So that gives me absolute value 2x minus 1 is less than or equal to 6. This has to be isolated before you can write your two inequalities or equations. Agreed? What's the matter? Sure, yeah. Okay, so let's write our two inequalities. This is an and problem. Agreed? Correct? And it's less than or equal to. So my first one is 2x minus 1 is greater than or equal to negative 6. Copy it down. The left side is going to reverse inequality in its opposite sign, correct? The second inequality is just going to be copied down without the absolute value. That's how I remembered it. Everybody see where I'm at? Add 1, divide by 2. So x is greater than or equal to negative 2.5. You could also write negative 5 halves. Add 1, divide by 2. So it would be what? 3.5. X is less than or equal to 3.5 and greater than or equal to negative 2.5. So my inequality looks like that, doesn't it? Correct? Because this is an and problem. Agreed? And then negative 2.5, closed circle, 3.5, closed circle, and they're right here. There's your graph. And then your interval notation would be negative 2.5 included, 3.5 included. Does that help on that? Any other questions on homework?